Good morning, my dear students. Today we'll discuss an important concept is called routing algorithms in computer networks. So before we are learning the routing algorithm, first of all we have to know what is routing. So routing is an important key feature of internet. That means whenever you make a collection of interconnected systems to share the information, that is called internet. Now how they are connected and how they are passing the information from one system to another system is identified by a routing. So routing is actually called as a path. Routing is also called as a path. It is a process of selecting the best path for a packet to reach the destination. That means whenever you make a network through a communicated devices, now whenever you are sending the information from source to destination, at that time it will select the best path to reach the particular source to destination. And here every intermediate computer routes the data to another computer and eventually it reaches to the destination. For example, I am sending from 1 to 3, so three systems are internet connected and they make a network. So when I am sending the information from 1 to 3, my source is first system and my destination is the third system, and it is interconnected with the intermediary computer is called 2. Now the information can be selected through the best path, and this selecting of best path is called as a routing. And now we can go for its path is calculated using a routing table. Sir, how to calculate the best path? So the best path is calculated by selecting the distance between the computers which are connected in a network. So and that information can be stored in a routing table. Like for example, this is S1, this is S2 and this is S3. So my source is S1, destination is S3, and I just want to travel from S2 to S3. Then they can be calculated which is the shortest path and which is the best path from S1 to S3. So that process is called as a routing. And next we can go for the routing algorithm. So there are three types of routing algorithms for selecting the best path for sending the data from source to destination. That is distance vector routing algorithm, link state routing algorithm, and the third one is Dijkstra shortest to path algorithm. So these are the three best routing algorithms in computer networks. So before we are discussing again the routing algorithm, we have to know about router. What is router? What is the use of router? Router is nothing but it is an interconnected device which is used to connect various networks that uses different technologies, media and frames and formats, etc. That is, router is nothing but it is a networking device. What it can do, it will combine or it is used to connect different type of networks as in one single network. And this router can be worked as a this router can be used in the network layer of OSI model. That means router can be used in network layer to make a network between the two different type of devices or two different type of networks. And here you can see this is a diagram which will explain what the use of router, how router can be work. So see, this is a router networking device and modem is another networking device. So through the router you are connecting two different type of networks. You can see this is a one network and this is the another network. See here existing of a client and here there exists of a network. This is regarding about LAN or WAN or MAN. So this is one network and this is completely another network. So you are communicating different type of networks, different type of various networks using different type of technology. This is regarding the client system and these are the normal local area networks, and this is regarding client 3, client 4 or some other computers. So there are different type of technology, different type of media and different type of frame formats of computers are interconnected. So through the router they can be communicated. For example, I need to access the network of these, so I connected to the modem and I just want to pass the information from internet to individual devices. So I am taking the with the help of router. So what router can perform? So router can transmit the packets based on the IP addresses. So what router can do, they can pass the data packets from internet different type of networks to different type of system based on their IP address. That means every device which is connected or which is exist in the network comes with individual IP address to share the information or to communicate the information between the devices. And the next, the packets are forwarded to the destination computer through the shortest route within a network. So what router can do, ma, they can find out the best path, and through that best path they can also forward the data packets to reach to the particular destination. For example, I need to send the data to D in the local area network. If for the D device I need to send, then the router will select the best path. What's the best path to send the data to the device through the IP address. So here we can discuss two different type of algorithms, that is distance vector routing algorithm, another one is link state routing algorithm. So before we are discussing the distance routing vector algorithm, these are the four important key points that should be remembered. The first point is it uses a routing table maintained by each router in a subnet for routing. What it can do, ma, it contain a router, and this router will send the information from intermediary computers or intermediate devices which are connected, and they can maintain a routing table. They can maintain one routing table which will be calculated the distance between the individual computers. Next, each router maintain a table containing the information about the best known distance to each destination. So that means each router is have each connected to individual computers, so they can maintain a routing table. Like router 1, it containing a different table, like same router 2, it having different type of routing table, and here we can calculate the distances. See the distances to each destination. For example, from A to D, A to B, A to C, they can find out. For example, A to B, what is the distance, A to C, what is the distance, and A to D, what is the distance. So that can be maintained in a routing algorithm. Each router, now A is A containing of one router, and this can maintain a routing table and to the destination. My destination is A to B, it will be calculated 3, or A to B we may reach from A to J, J to H, H to D, D to C, C to B, like. But in that they can find out the best path to reach to the B, or nothing but the best path to the destination. And the third point is the metric is used for routing could be the number of hops, comma, the queue length, or the time delay in milliseconds. So what is the measurement for routing? So the measurement of routing could be taken the number of hops, that means number of hops. Here you can see, for example, I just want to send the data from A to J. Now A to J there is a direct connection, and this direct connection may take 7 hops, the 7 milliseconds of delay, or you can say A to E, E to I, I to J, they can be calculated 6 plus 2 plus 4. So this comes to the matrix used for routing the table. And the last one, the tables are updated by exchanging the vectors to directly connected neighbors. So whenever, for example, you can see there existing of a directly connected from A to J, and at the same time it will be connected, every time it can be changed the destination by source. A to E, now E will become as a source, now E to I, now I will become as a source, and I to J, like that it will be calculated. That means A to E, and then E will become E to I, now they can be calculated I to J. So in this mode they can be updated the tables which are given in the router. So this concept is called distance vector routing algorithm. Every time they can be calculated the distance between the each and every neighbors which are connected to the source to destination. And the next concept is link state routing algorithm. In link state routing algorithm, as the name suggesting here, each and every state of the connector will maintain a link. Through that link we can calculate the best path. See here the following two very important points to be remembered. It is a dynamic routing algorithm that takes into an account the complete network topology, all delays and bandwidth when choosing the routes. That means whenever you are going to choosing the route, for example, my source is A, destination is D. Whenever you are going to choose any path at that time, it will be considered. That means it will be take considering regarding what type of network topology they are and what are the delays in each and every node and bandwidth when choosing the routes. What is the bandwidth of A, what is the bandwidth of B, what is the bandwidth of C, at the same time what is the delay between A to B and B to C, C to D. Each and everything will be calculated in the link state routing algorithm, and each router does the following very key concepts. That means every time, for example, A is containing some router and B is containing some router and D is containing of some routers which are used to communicate with each other. At that time they can follow the following rules. First one, the router learn about its neighbors and their addresses. That means whenever you are existing of a is the source, at the time it will find out the first what are the neighbors and what are the neighbors IP addresses. A contain the neighbors of B and E. Like you can see, A contain the neighbors of B comma E. So A to B is 5 and A to E is 4. That is the first step. Second one, measure the line cost to each of the neighbors. What is the line cost of each neighbor? For example, A to B, what is the line cost? 5, and A to E is what is the line cost? 4. At the time it will select the best line cost, that is the lowest cost of the neighbor. Then build the packets containing information it learn. So whenever it is calculated the low cost of line, then automatically it is ready to transfer the data. And fourth one is distribute the packets to all the other routers. Then what it will do, it will distribute the all the packets to the other routers. Compute routes with shortest path to every other router. It will compute. For example, I just want to reach to the D, A, B, C. 5 plus 2 plus 3, that comes to 8. 8 plus 2, 10. The line cost is 10. Again they can go for A to E, that is A to E is 4 plus E to F 1 plus F to D 7. 7 plus 4, 11. 11 plus 1, 12. So 12 is the line cost of the another path which is chosen from A to D. So at that time it will take the best link state from A to B, B to C and C to D. So this is regarding about link state algorithm in computer networks.